Capture. Okay, got it. Hangout is live.
Do it.
Or no. Why? I can't remember which one was. Screen share. There you go. Yeah, let's show the entire screen. That's.
You want to share screen press.
Yeah, I saw that. Okay. Now we're good. Okay. So let's just go to Android Studio. I would go. These are all on GitHub, but I'm just going to show them inside the IDE because it's easier that way. Okay. So the first thing I want to show you guys in the wrong project. Well, that's a bummer. I'm going over collections, but this time I'm showing you guys better code examples, posting from GitHub, that kind of stuff. So the first one that I'm going to show you is maps, because it is the collection that has 2 values as opposed to 1. Maps have a key value pair. Let's see. Oh, I have it up right here. So this is the app I made just to sandbox it to show you. You can put in a key and then a value that matches to that key. So, for example, we could be like Matt sucks. Stinks. Is a jerk. For that one. And then we can go with Brett
Is a bigger jerk.
is a bigger jerk.
Suck it, Brad.
Or lazy.
So-
I mean,
Oh, it's definitely.
So this just Brett.
now you need to do Andrew is awesome.
So
Yeah.
is lazy. I just cleared him. Andrew is awesome.
That's how many actually I put on my birth certificate. That's how my mom did it.
Charlie sounds funny. Okay. Maps are not sorted. And sorting them is kind of costly, from basically my understanding from what Barney was talking about. But trees are sorted. However, trees are not key value pairs, they're just values. And then there is lists, which are like arrays, but they're expansive. So they're neither sorted nor are they key values. They're only values.
Can I add something?
Yep.
To the sorting? Yes, it would be expensive to sort it. It's actually, you rarely get any benefit out of sorting it. Based on the way the hash stuff is set up, you actually, all the speed comes from the fact that, I mean, you don't really need to. When you're using a key value pair, you generally don't need it sorted. If you were indexing something in order, then yeah, you would.
Right. That's the only time you need something sorted
But
anyway.
yeah, you just can get to it straight away.
Right.
Really, based on the way the hash is set up, it directly correlates to an index in essentially an array anyway.
Yeah. So all good with that. Matt has his headphones in for some reason.
I'm still listening. I'm not listening to him.
So here's how I did this. To value into a map, it's actually just a single line. It's just a single command called put. Right here. So here's the 2 lines that are just getting the text from the text boxes, right?
What is
Deciding
M1?
what?
What is M1?
M1 is the name of the map.
Okay.
It's a global, just part of the entire activity called map with strings to strings M1.
Oh,
So this is how you declare. This is how you. Yeah, I should have gone over this first. This is how you declare a map. You give it the key and value data types, and then you can just say it's a new. And if you implementing a hash map, you can do hash map. There's other map types, but you can assign any of the actual types to the abstract type map.
For our benefit, what's the difference between map and hash map?
A hash map actually implements the hashing feature. So
what's a map?
Map is abstract. It's not actually an implementable class. All of the other maps come from class map.
So,
So-
is there any reason why you chose to do map there as opposed to one of these lower?
No, I could have done this exact same thing right here, and it would be doing the same thing for this example.
And with hash map, you still use the angle brackets and everything.
Yep.
Same way.
Yeah, all the maps you're going to be using the same exact syntax. Then, so the put command, if I type it out here on the IDE, put will accept the parameters that you created the map with. So since I made it as a string, it accepts string. Pretty basic there, that it's accepting the actual key value pair. And so in this case, I'm getting the text from the two text edit text, converting them to strings and putting them in. And that's what these two lines do. Then I just I'm printing out the map after I put it in. If you put a map value in that already exists, it will just replace it. So in my case, I put in a condition to prevent duplicate key entries. So I check to see if there's a method called contains key, and you can pass in the key and see if there's a value inside the map with that key. And you can handle it in some sort of way. If you don't do that, when you do a put, if you're putting over something, if you're putting in a value key pair and that key already exists, it overwrites the value in that key. Does that make sense?
Pretty much what I expect. I mean,
yeah. So,
updating your
yeah, it does an implicit update. It doesn't throw an error or anything saying like this value already exists or anything, or value exists exception or anything like that, or key exists. It's just it puts it there and replaces.
I feel like I should bring it up just in case thinking about it, the problem. Make sure you're checking your case on your stuff.
It's case.
Yes, it is case sensitive. Yeah, I could show that here. I try to show that here.
What happened?
So if I put in B, and then also put in B,
with only one N.
you'll see B and B both exist. This is the case. So on maps, the keys are the case sensitive. In trees, you can't have. You can have duplicate values as well. But when doing its sorting on a tree, for example, the sorting is case sensitive, and that's what I'll show you here.
Can you do a force case? So say like store it all uppercase.
Well, you could. You just have to actually convert it to uppercase before you store it.
Okay. So like before you put actually take.
I would just put this as to upper. I don't know what the two upper case is, but this right here before I put it in. Okay.
I just didn't know if you could use those functions within.
So I would just do this right here, and convert it to uppercase.
Okay. Yeah. And you can do two lower.
Yeah. There's all sorts of. I could trim it. Trim removes empty spaces. That's part of strings. That's part of the string class. It removes the white space.
You can specify if you want to change what you want to actually. Usually by default, most languages it's white space.
Yeah. And some languages have a right trim, left trim, as opposed to a trim, or in addition to a trim.
The reason I brought the two up is that would
Yeah.
keep it where it couldn't.
Yeah. So it depends on your use case. Here, I wanted you guys. When I put this up, I wanted it to be. I wanted to play around with some UI stuff as well. So that's why I added boxes and stuff. So we can look at the next one, if we're good so far. I don't. To clear it, it's dot clear. It's also something that shows up on the IDE, as well as on the web page from Android that explains about maps.
Can you delete a specific?
Yes. Let me see if I can. I think it's dot remove. Yeah. So you pass in you call dot remove, and then the name of the key.
It says that it's taking in an object.
Yes.
To a literal. So
Well, probably because you can do integers, you get strings, and since those are technically objects.
Well, let's check. I can check it up.
So you can. It's just saying whatever object it's being stored as.
Hash. Yeah.
At least that's my understanding. I did actually look at collections and maps.
I don't know how it handles it, like if you're typing strings directly in.
Well,
In string variable first, and then have string variable.
well, string literals are converted to
It
kit.
looks like
Removes all specified by. Oh wait, it's remove object key. Removes so.
Yeah, you're right.
Yeah.
I guess
Just whatever the object type is. Yeah. So I mean, literals automatically string literals automatically convert to string objects. Okay. Because that's how they're interpreted, right? Anyway, make that clear. Okay, so we can reopen a different project and reopen trees.
And so what's a tree?
Tree is it's like a, but it's the idea of a link. So do you understand the idea of a linked list already?
I've really learned about it. Yes.
Okay. This on the actual Hangouts.
Kind of the way I have come to understand it is just wanting the last, I guess, element of each array or something points at the beginning of the next array kind of thing.
Yes.
Sort of one.
Is there any way for me to do a drawing on here? Well, I'll just go to Paint. How about that? I'll just continue to do screen share.
It's that pencil on the top, isn't it? Is that not on the top left? Is that not it? Drawn, drawn.
Okay, searching for a face, apparently.
Oh, maybe you should just draw out a person's face. Never mind.
Here we go. What? Okay, cool. So, with the example of lists, well, why can't I? Oh, okay. So you have each thing is a node. And how do I delete things? Oh, yeah, it's not very great. So each, in a linked list, everything has a node. Nodes have multiple objects. So there's also a little bit of difference for what the start of the list is. And normally, the end of the list is null terminated. So each of these objects will have basically a next, and all that is this actual pointer to the next object.
And each element would have that?
Each element would have a next. The last element in the list, next points to null. And that's how it knows that it's the end of the list. Okay. So you prevent, on lists, you do not allow null inputs because they're usually null terminated.
So if we were to put null in there earlier, we would think that the tree was completed before it actually.
Right. So let's just say we have a list that holds strings.
Yeah.
Right. And we have a.
We have like in C++ with string, you have that null character at the end, you put a null character and further forward at the end of string.
Exactly.
Right. Right. And so strings are null terminated as well. So
strings
linked
are
list.
technically a linked list of characters.
Yes. Linked lists have the opportunity to insert a new list anywhere inside of it. So you can say insert after A. And if I tried to insert null here, what it would do is when this goes here and it says this is next is null, it thinks it's the end. Yeah. And so it doesn't even think to go and get anything further. And so what you have is this, and if you have a problem here, it doesn't know how to clean this up because your delete of the list goes, what it usually does is it iterates the list and removes the top and removes the head and what it does is remove this, and this one becomes the new first object. And so we did that, and this becomes a null, and remove this, and be like, oh, that's the last object, I'm done. Yeah. And everything that was past it would be memory linked. Yeah. So normally you prevent null entry on lists. Some lists also have a last, which points back up, so you can iterate not just down, but you can iterate up from anywhere. That also speeds up efficiency. It does it decreases the efficiency of inserts because you now have to manage 2 pointers every single time you insert or delete. Yeah. But it does allow you to iterate from both directions. Okay. So a tree uses the same idea of having nodes, but instead of having a next and last, it has a parent. This is a binary tree. There are other types of trees. I'm not sure which one it's actually implementing. I didn't find out about that. Most binary trees have this. So you build a list, and I want just like draw on here so it's there, but it looks a lot like a family tree. In a tree, however, all of the objects are on the ends. So all the other nodes are not actual values. They are kind of intermittent. Wow, I can't think of words. Intermittent values. So what it means is if this is A and this is F, this would be E, F, G, H, I. Let's go with I and Z. Okay. This would be a value between A and F, or it would know that the child values hold values between A and F. This right here is just a headed list. It doesn't have anything at all. And this would know that it holds values that are past F, because that is the furthest right character on the other string. So this knows everything here is either F or less. Right? Everything from here on out is F or less. Everything here is greater than F. Okay? And so when it gets here, you have that same concept. Everything this direction is going to be I or less, or between F and I, inclusive of I. And everything here is going to be between I and Z, inclusive of Z, exclusive of I. Okay. Does that make sense? You always do one direction where you say it's inclusive of one and exclusive of the other. So if I put in J, if I inserted J into this list, what would happen is this would no longer be I. It would actually insert two child elements.
One would be J and then the other would be I.
One would be I would be on the left, and J would be on the right, because that keeps the ordering. So the way it inserts values explicitly has a sort. And the way you iterate, there are other objects that it puts in.
Explicitly or implicitly?
Explicit. It doesn't tell you that it's sorting, but I'm saying it always sorts on input. By the way it inputs, it keeps it sorted. Okay. So it keeps assorted.
And it does that for you.
It does that for you. Okay. So which is why if we do, if I show you my, I opened up trees. I'm gonna run it and load it.
Back to the screen,
You know, that is a question that I wasn't prepared to answer because I didn't know. Why don't I? Yeah, this is my entire screen. I wish I could do everything except for the Hangouts, right? Wouldn't that be great? Yeah, it does that. So.
Well, you want to pick these screens. You want to pick this screen.
Well, these aren't different screens. It's just duplicated.
Because I think what it did is it just moved itself.
But once I minimize it, it's gone.
Well, you have to pick the actual window that's working.
Oh.
It's not looking at your entire screen. It's looking at the window. That's what it gave you before was this window. So the whole time.
No, it said entire. It asked for entire screen.
Oh, okay. Well, I didn't see the entire screen, so you're probably okay then.
Oh, I just clicked stop sharing. That okay, so that was screen share. So I did screen share and I clicked entire screen. Yeah, so we're good. Wish I could choose multiple things. Well, let's just share trees for now. Oh, that's the wrong trees. Well, let's just share Android Studio for now. Which for some reason is calling it maps. Yes. It's because I duplicated it from previous project. So if we show the preview here, main layout, yeah, make sure I'm on the right project. Just so you guys know, if you have problems with preview on Android Studio, I found out it's the reason if you've downloaded the Watch API and your layout includes things that don't work for watches, you need to manually pick something below Watch. Anyway. That's just a thing.
Yeah, I'm trying to avoid the watch stuff.
Yeah. So trees are very, very much like a list in their usage. I'm doing a tree set so that I can also, for my example, be using trees and sets at the same time. Sets are like lists in the sense that they hold collections of values, and there's not a key value pair, it's just a value. they're different in the sense that sets cannot hold duplicate values by definition. So you can't have capital A and capital A. You can in a list and in most trees as well. Like a hash tree, for example. Anyway, the adding a new object, instead of put, you use add. And instead of having both a key value pair, you just have the value. Okay. So if this started running, it did. So if I put in 1, and then I put in 2, and then I put in 1, 1, you'll see where the input is put in. All of these, anything that starts with 1 is going to go above 2 because it's sorted using, it's sorted as a string, right? Because that's the object. So also in ASCII values, A is above lowercase a. And when I'm displaying it, it is continuing to sort it as I put it in. The display, in both cases, I've used an iterator for displaying. So a for loop iterator I could have done this with the while loop as well. Make the iterator saying it's this dot my tree is the name of the tree, and calling the iterator function returns an iterator object, which you can then store into your declared iterator object. Does that make sense there? This, we all get on this part of code? Okay. Iterators have a has next function, so that's just my condition. Has next will become false when there is no next object to iterate to. And you can do, in this case, I'm just printing out the value of the next, using I dot next to print out the value from the next object of the tree. So that's pretty much it. And I'm setting that all to a single string and then returning it as a string in the function. That's just I mean, you could be doing it other ways, but cool. Also, trees have an is empty. Both trees and maps have an is empty. So returns true if there is no objects in the collection.
Do you have your tree example on GitHub?
I just removed it. I had an issue with it, so I removed it. I'm gonna pull it back up in a second. Yeah, go for it. Once I get it up. I did this all by scratch by myself. I mean, for when I looked, I used a lot of Stack Overflow for help when I ran into the issues. For like when I was like, how should I display a tree? Because I didn't know if you could just iterate through it, and you can. They're just like, well, just do an iterator and iterate through it.
So the main point of the tree is the fact that it auto sorts it for you after adding. What's the main primary benefit of the tree? Why would you use a tree versus not anything else?
That is one of the main. That's basically the
Main thing.
So yeah, because you basically you have trees, you have lists, you have maps, and you have sets.
Or what? No, of a tree that like.
For example, the phone book.
Think about a phone book.
Yeah, when you add a new person, it automatically inserts them where they belong.
Yeah. Yes.
That's the best.
Trees are really well implemented. They have a lot of efficiency. If you do not care about sorting at all, then all you care about is the dynamic amount of lists, and you want to allow duplicates, then go with just a list. I think
you actually have to manually sort. Well, you'd have to call it.
You'd have to call a sort function.
And so that'd be probably expensive on the resources to do that all at once.
Right, because the way a tree works as well. I don't have this.
think it should be more useful. Like let's say you
Trees-
have 1,000 records and you want to add something, it's supposed to have to sort the list every time you add a thing. Just add it in.
Trees also sort faster.
More efficient.
Yes, because of the way they're implemented. I'm going to pull up the paint just because it's easier for
And I
me.
think you explained this, but I missed it. Trees only hold a single value, or can they hold multiple? Oh, so you could create,
All of these hold objects.
so the telephone is the perfect thing. You could create an object with multiple attributes.
Yes. All of these can also, the object can be another collection. Your trees, every object in the tree can hold a list, an array, a set, another tree. There is no end to it. I didn't get time to show that example and build it up for you guys. I can if we need to, but it's not any different. It's just a multi-dimensional collection. So you use the first collection, to reference the first object, which results in having a collection. So you have to do something with the collection. So when you insert, so let's do our basic tree here. And my drawing skills are impeccable.
Brad, we need to get where we can do the next.
Yeah? Yeah, I just want to do this part real quick. When you insert or remove new values, for example, let's say I insert a new value here, right? Let's make that red. This is the new value. All it does is it finds the location it needs to be. So let's say it found it by doing, and the search algorithm of this is a binary search, because it's every single time it cuts the size of the list in half before you need to find it. And it knows it needs to go here. So the sorting that needs to be done is only on this part. So if it needs, just wherever it's at, it's going to add a leg, and so it's going to add a second leg, where this one goes down into that, and then this becomes no longer a child element. Now there are instances where your tree will become unbalanced because of sorts. And this is something you won't have to know, because Java will be doing this for you. When a tree becomes unbalanced, it refactors it. Normally what they do is if it would never get to this far off, but you can see how this is the start of the tree, and there is nothing over here. It would always, every time you add new things, if it causes an imbalance by saying that this has gone down 2 more rows than the other rows above it. So each one of these has a level. I guess that's what I forgot to say. So you would call this level 1, this level 2, right? If you ever get to a point where there are no child elements over here, the greatest child element is level 1 here, and you have a child element down here at level 3, it will refactor it so they're all level 2. And then if it can't refactor, so it always tries to keep it so the number of levels is the smallest possible based on the number of elements you have. So that's how it keeps.
Automatically.
That's what it does. And so then your sort on the insert becomes a little pricier if it has to refactor, but it's still faster than calling a full sort on a full collection. Because on a full linked list, it has to go through the entire thing because it doesn't know whether or not it was already sorted, right? If I have a list, I don't know if it's sorted based on values until I call .sort, and .sort has to look at the entire list and see what's sorted and what's not. So I guess we should get into the next thing so that we can do the Java beans, right? Is that what you're on?
Yeah.
Okay.
I don't have the connector plugged in.
Okay. Do you want to? Can you use mine? Do you have it on your GitHub?
Well, it's thinking I'm trying to set up.
Oh.
Wait, do you have an idea?
What?
Right. So I use
Can we pause the live?
Can you just upload your source